Good morning, everyone. Today we will revise together chapter 14. This chapter is talking about the sound. What causes sound is the first lesson. First, I have different kinds of particles. Here is solid particles and liquid particles and gas particles. Sound happens when the particles of the matter vibrate. Means if those particles vibrate or move very quickly, they will make the sound happen or travel from the matter. Okay, which matter will sound travel through it fastest? Solid. This one. Why? Because the particles are beside each other tightly. So it will be easy when first particle vibrate, it will make the second one to vibrate, the third one, the fourth one, until it reach the last particle. Because they are beside each other tightly, they will make the sound travel through them easy. So first matter that make sound travel through it fastest is solid. Then liquid because they are beside each other loosely, so the space between them it's not much big as gas, so they will travel the sound through it faster only. Then the last one or the slowest matter that make sound travel through it will be gas. Why? Because the particles are not beside each other at all. There is a huge space between them. So it will take more time to make the sound travel through it. That's why it will make the sound travel through it only fast. So sound will travel through solid fastest, through liquid faster, through gas only fast. Okay, I can have sound around me while I'm playing or talking or whatever. Some sound will be pleasant sound and other sound will be bother sound. Bother means that it is noisy one. A pleasant will be good for you or it will not hurt your ear. How the sound happen? It happen because vibration. Vibration means move back and forth very quickly. So when the sound move back and forth, the movement of it will make the vibration. And because of this vibration, the sound will happen. So sound will happen because of the vibration, because of the vibration. What is the meaning of the vibration? The movement of the particles or the movement back and forth very quickly and fast. Pitch is how high or low sound is. So remember while you are talking about the pitch, remember the difference between high or low sound is. So how can I know that it is high or low sound? The pitch is when the vibration is very quickly, it will cause high pitch. But when the vibration is slowly, it will cause low pitch. So pitch will be high when the vibration is quickly, and pitch will be low when vibration is slowly. So when the particles vibrate quickly or anything vibrate quickly, it will cause high pitch like me now. Okay, but when the particles or any object vibrate slowly, it will cause low pitch. Okay, this is the difference between the pitch and what is it. Now, some instruments, they also make sound by vibrating. This stringed instrument makes sound when the strings here, those are strings, when those strings vibrate by blocking it or rub it with a bow, it will make sound. Which one will have high pitch and which one will have low pitch? The shortest one, okay, the shortest one, and the thinnest one, the tightest one, will make faster vibration. So if it make fast vibration or quickly vibration, means it has high pitch or low pitch. It will has high pitch. Okay, so the tallest one and thickest one will make low pitch, and the shortest one with thin and tight more will cause high pitch. Okay, tallest one here, it is tall, thick, and it is not tight as the short one, so it will make low pitch. The shortest one, the tightest and thinnest one will cause high pitch. Okay, this is the difference between higher and low pitch in this stringed instrument. Okay, I have also sound. I also made sound by while I'm talking. Also, the sound happen. So what happens? So it makes sound. I have inside my neck something called the vocal cords. Vocal cords are inside my neck or after the throat, inside the throat, okay? Those vocal cords are also tight inside, okay? So when those vocal cords, air passes through them, the air passes through them, it will make the vocal cords to vibrate, okay? If the vocal cords get vibration more or they are tightened more, they will cause higher pitch. But if the vibration between them is not very fast, it is slow, and they are not tight, okay, so you will get a low pitch. Like what? Now I have inside my throat those vocal cords, okay? When the air moves through them, the air will make them vibrate, okay? The air will make them to vibrate. So the vibration of the vocal cords will cause sound. If the vibration is very quickly, they will be more tight, okay? So we will make a high pitch. But if the vibration is slowly, they will not be tight, okay? So it will make low pitch. Like what? I will make now sound with high pitch. If I shouted, okay, like ah. So the vocal cords inside my throat, the vibration between them is very quickly. So it will cause this sound because they tight more. They are tighter more, okay? They get more tighter, okay? But when I just talk like the vibration between the vocal cords will not be very quickly. It will be slowly or just quickly, okay? Not very quickly. So they will not be tight, okay? They will not be tight. So if they are not tight, they will cause only low pitch. So high pitch when they vibrate quickly, very quickly, and get more tighter. Low pitch when they vibrate slowly and not become tighter, okay? These are the vocal cords that cause sound inside your throat. All of us should have those vocal cords to talk or to cause sound. I have also some instruments here that cause sound. All of those instruments like clarinet, saxophone, or trumpet, all of those are air instrument or wind instrument. Okay, they make sound because, or they cause sound because the air, okay, vibrate inside them. So inside the clarinet or saxophone or trumpet, all of those are wind instrument. They make sound when the air inside them vibrate. When the air inside them vibrates, okay, they make sound. They called what? Wind instrument because they make sound when we blow air inside them. So when you putting them between your lips and blow air inside them, when the air vibrates inside them, the sound will happen. Okay, so that's why we call them wind instrument. Okay, so they make sound by blowing inside them. Okay, and we can change the sound inside them if we just blow a little air, or if we just press some buttons here, open it or close it, so we can make different pitch uh, by blowing air inside them and by vibrating the air inside them. This kind of an instrument called oboe, okay, oboe instrument has double reed. What is the meaning of reed? Here it is the reed. This reed are double one, okay? It is a thin piece of wood. Should be here, and it is a thin piece of wood. When you blow on this reed, okay, when you blow, you should put this reed between your lips and blow air inside the oboe, okay? So when you blow the air, so this reed will vibrate. So at first, you will put them, okay, put this point in your lip, then blow the air. Blowing the air will make this part of reed vibrates, okay? So when this part of reed vibrates, the air will enter to the oboe, and also the air inside it will vibrate too, okay? So vibrating air inside the oboe will cause sound. How can I change the pitch? If I just pressed into this button, close it or open it by using my fingers, okay, I can change the pitch of sound. I can change it. So I can make the pitch high, okay, if the vibration of the air is very quickly. So I should open some and close some. I can also change the pitch and make it low also by pressing on those keys or buttons. Now we finished the first lesson in the chapter. Let's move to the second one. Okay, now second lesson, how does sound travel? How does the sound travel? We said first that sound travel through matter. So if there is matter only in our world or in our earth, okay? But if we go out to our earth in the space, there is no matter. There is no matter out in the space. That means that is no matter means the sound cannot travel through out of that space, okay? Because what? Because there is no matter out of the space, so the sound cannot travel out our earth, okay? Because it needs matter. It needs solid, it needs liquid, it needs gas, it needs the particles to make it vibrate, so it can travel through it, okay? Now, here it is. We can see the sound travel through the sky, means that there is an air in the sky, so it can make the sound travel. Also, the sound travel through the water or the liquid. We can hear the sound of the dolphins or whatever, okay? That's why, because the sound travel through the liquid, okay? Here it is, this kind of toy. You can make it in your home. The sound will travel through it, okay? All of it is parts of solid. So if you talk here in the first one, the air, okay, will vibrate inside it. Then it will make this string or rope to vibrate. So vibration of this string or rope will make the sound to travel to your ear, okay? So sound to travel through the spaces, through the matter, sorry, solid, liquid, and gas. What is this? This is called echo. What is echo? Echo when the sound go, okay, vibrate through the matter, then bonus to something, okay, then gets blocked by something, then bonus back to you. This is called echo. What is the meaning of echo? When you are, okay, talking in an empty place, when you are talking in an empty place, so your sound will travel or move in the particles of the air, okay? Then when it gets blocked, okay, when it gets blocked or strike on an object, okay, it will bonus back to you so you can hear your sound again, okay? You can hear the sound again. You can make it in an empty space, the echo, or in a cave, okay? So you can hear it. The sound travel or the wave of your sound travel through the air, then when it gets strike to an object or get blocked by an object, okay, it will bonus back to you so you can hear double from your sound. You can hear your sound double and up, okay? This is the echo. What else I have here? Compression waves. What is compression waves? Compression waves is the movement of particles, okay, that when the sound move, okay, it will make it. Sound waves are called compression waves. The sound waves called compression waves. What is it? Here it is the compression, okay, then it become easy and space between them, then become tight, then become easy and space between them, then become tight. So when the sound wave become tight to each other, we call it compressions, okay? Compressions are the tighter waves and refractions are the, okay, the opens wave, okay? So what are the compression waves? It is the movement of particles, okay? Means the particles in the air or in the solid or in the water, they are moving by waves, okay? How? At first they are compressed together, then refract, then compressed, then refract, then compressed, then refract, okay? So we call it compression waves. It is like a wave, okay? They are moving like a wave. Wave come high, okay? Then low, right? So they are compressed, then refract, then compressed become high, then low, then compressed become high, then low refract, okay? Then compressed, then refract. This is called the compression waves. The movement of particles, how the particles move to make the sound travel, okay? How the particles of the matter move to make the sound travel. This is called compression. And we named it as wave because they are moving like the wave. Okay, wave become high then low, high then low. So the sound particles also become compressed, then refract, then compressed, then refracted like this. Okay. Particles being squeezed mean like compressed. Okay. Then spread apart. Refract means spread apart. Okay. squeezed, like when you are squeezing something to get the water out of from it. So squeeze means become beside each other, okay? Then spread apart means become away from each other. Here it is the spread apart, okay? And here it is the squeezed particles. Squeezed means become beside each other, like when you squeeze the lemon or orange or whatever to get the water from it. Okay, you become it, you make it very tight to take the water or the juice from it. Okay, that's how also the particles of the sound squeezed to each other. Then spread apart means become away from each other. Okay, that's how the conversion wave happen. How can I measure the waves? Okay, I should first. How can I measure the compression wave? How can I measure the compression wave? I should take the distance between two compressions or two refractions. So choose, okay? You can take the space between two compressions, means between two squeezed particles, or between two spread apart particles. Okay, it's up to you. When you measure the sound, you can take the space between two compressions to know how wavelength is this, okay, sound, how much the wavelength will be, okay, or how long this wave will be. So how can you know the wavelength? By measure the space between two compressions or between two spread particles, okay? Between two spread means this place to the other place that are spread apart particles inside it, or between two compression waves from this compression to the other compression. Okay, it's up to you to know the wavelength. What is the meaning of wavelength? The length from the center of the compression, take the center, okay, to the other center or to the next center of compression. So if you need to measure the compression wave, you should start from the center of the compression to the other center of the next compression, okay? The next compression, so you will know the wavelengths of this sound, how many or how much will be, okay? Now also the sound travel, okay, here it is this picture. Which one, A or B, will the sound travel through it fastest? Of course A. Okay, why? Because it is near the source, near the police car. So A will hear the sound fast than B. Okay, because what? Because A is not the source of sound. A is near the source of sound. It is close to the car. So A will hear the sound fast than B. Okay? Because what? The waves here get loose. Okay? Get lost here while the sound is travel. The waves lose some, okay, sound. So B will not hear the sound as clear as A. B will not hear the sound as clear as A because the wave, the sound get lost while traveling, okay? While the sound is traveling in the waves, it get lost some sound, okay? So B can hear the sound more not clear as A. Let's move now to our ear, how our ear work, okay? At first, I have the outer ear. Here it is, outer ear. Here it is, the outer ear that I can see and I can touch, okay? that you can see and you can touch by your hand. It's called what? It's called outer ear. This is part of ear that collect the sound waves around you. So all the waves of sounds that are around you, the outer ear will collect it. Okay? The outer ear will collect the all the waves in your place around you. Then what? Then move in the ear canal. So become into the eardrum. Eardrum, it's like the drum that you are hitting it by using any kind of wood or whatever. So you have eardrum inside your ear too. Because the air or the waves of sounds are vibrating, let's read this one. Now I have here the waves of sound are coming to your outer ear. They are moving just slowly and just moving in the air or vibrating the particles. They are vibrating the particles of the air. So what will happen because of this vibration? It will hit the drum in your eardrum. It will hit the drum in your eardrum. The sound wave, okay, will hit the drum in your eardrum. This eardrum is kind of thin skin, a very, very thin skin that is stretched, okay, across the ear. Stretch it here, stretch it, okay, and stuck here. It is a very thin skin, okay. So when the sound is vibrating, it will hit the eardrum. What will happen after hitting the eardrum? This eardrum will vibrate, okay? Your eardrum will vibrate. What is the thing that it is beside your eardrum? The middle ear. It contains 3 kinds of bone. 1, 2, 3. Okay? 1, 2, 3. I will erase and I will show it to you again. Here it is, the vibrating of the air hit the eardrum, so the eardrum will vibrate. Okay, vibration of the eardrum will make the middle ear that contains 3 kinds of bones or little bones. Okay, they are very tiny bones after your eardrum. So I have 1 bone, 2 bone, and 3 bone. Okay, eardrum will make those kinds of bone to vibrate too. Okay, so the eardrum vibrate, it will make the bones to vibrate too. Okay, those kind of 3 bones are from your middle ear. Okay, then what will happen? I have here now the inner ear. Here it is, the inner ear. Here it is, the inner ear. What is the inner ear contains? It contains kinds of something shaped like a shell that you found it in beside the sea. Okay, it's shaped. It has a part shaped like a shell. Okay, this part of shell is filled with water or liquid. Okay, this kind of shell is full. This kind of shell or part of shell that it's filled with liquid. Okay, so when the bones here, the 3 kinds of bones in middle ear vibrate, it will hit also the, okay, the movement of the bones will make the tiny hairs inside the liquid to vibrate. So this shell contains liquid with tiny hairs inside it, a very small tiny hairs inside it. So the vibration of those bones will make, okay, the tiny hairs inside the shell to move to or to vibrate. Okay, so the vibration of the tiny hair will send signs or nerve signs, okay, signals to your brain so you can hear the sound. All of this process happen in maybe less than a second. All of this process, what happened? Sound vibrating and move, okay, to your eardrum. Eardrum get hit by the sound, then vibrate, then make the middle ear vibrate, or three little bones to vibrate, then make the hairs or the tiny hairs inside the shell or inner ear to vibrate. Vibration in the hairs or tiny hairs will send a nerve signals to your brain, so your brain can know what the sound is around you, so you can hear the sound. All of this happen in less than 1 second, less than 1 second. Okay, this is how our ear work. Now let's move to the sounds of the animals. Okay, I have sound of zebra. Zebra makes sound by vibrating the vocal cords like us, okay? Vocal cords and also the lips. Its lips make sound and the vocal cords make sound too. This one is insect, kind of insect making sound, the katydid or the cricket making sound by vibrating the wings, okay? Rubbing the wings to each other, rubbing the wings, its wings, so it can make sound by rubbing the wings. I have this also kind of animal making sound, male seal, its roar or make sound by also vocal cords and its nose and some kinds of parts in its body too. Okay, let's move to, here it is. Here it is the vocal cords of us and the vocal cords of the animals. Okay, so some animals making sound by vocal cords, and some animals making sound by their vocal cords and their lips or whatever. Okay, so we cannot hear as a human. We cannot hear as a human all kinds of sound. Okay, we can hear some sounds only, but the animals can hear more sounds than us. Okay, so we can hear only some sounds, but the other sounds we cannot hear it. Okay, so now let's move to the bat, how the bat use its sound to eat. First, it send sound waves. So when the sound wave, like the echo, okay, when its sound wave strike to an object, it can know that this object is food or something that it gets hitting by it will hit by it, so it can know, so it can find its food by using the sound, because it's not have a clear vision. Okay, its eyes, it's not have a clear vision by using its eyes, so it use the sound, send waves. Okay, we cannot hear the sound waves of it. It can send waves sound. So these waves, when it gets struck by an object or any animals or kinds of insect, it can know that it is a food, so go to eat it, or it can know that it is something it will get hit if it is keep flying into it. Okay. So this is how the bats find their food. Okay. I said we cannot hear all the sounds like the animals. We can hear only the middle of the sound, but some animals can hear more sound than us. We finished now the chapter, okay, and we will answer the questions tomorrow together. Thank you.